Okay, question 6 from the trial exam is question 7 from paper 2, 2018. We have the interval 0 to pi over 2, and we have to solve this equation to find all solutions in that interval. So looking at this, there's various things we can do. I'm just looking at the sec here, and I'm thinking if I can write everything in terms of the basic building blocks of my trig function, so sine and cosine essentially. So I know that if I take 4 sine x, according to this, if that's equal to sec x, then it must be the same as 1 over cos x, using the third letter rule. Okay, so third letter of sec is c, which means that it's the same as 1 over cosine. Now, multiplying across, I'm going to get this. So I'm going to get 4 sine x cos x is equal to 1. At this point, a trig identity should be leaping out at you. If it isn't, you need to learn them, okay? Looking at that, I can tell that sine of 2x is identical to 2 sine x cos x. So I can tell because I've got the sine x and the cos x as a product, and having the 4 is quite nice as well. Now, if I double this trig identity on both sides, I'm going to get 2 lots of sine 2x, and that's going to be identical to 4 multiplied by sine x cos x, which is exactly what I've got here. So using an identity, which is true for all values of x, I can make a straight swap here, and I can write this as 2 sine of 2x, which is equal to 1. Now, if I divide by 2 now, we get sine of 2x is equal to 1/2. And I have to solve this equation in this interval here. Okay, so I'm going to have to make an interval adjustment in a moment. So let's first find the principal angle. So let big X equal 2x, such that now if I replace the 2x with big X, it just makes the whole situation a lot nicer. Okay. So my principal angle, X, is going to be the inverse sine of 1/2. Okay. The question is in radians. It's not stated, but you can tell because of the pi over 2, which is 90 degrees. So if you set your calculator to radians, if you don't know this angle, it doesn't matter. Just set it to radians, do the inverse sine of 1/2. You would get 30 degrees. Well, you shouldn't. You should get pi over 6, but that would be equal to 30 degrees. So that's your principal angle. Okay. We can then put our principal angle on our cast diagram. Before we do that, let's just adjust the interval. Okay, so we're going to adjust the interval that we're working in. So we're no longer working in between 0 and pi over 2 because we're talking about 2x now. So we're going to have to double everything. That's going to be pi. So we're going to look for angles in the first half turn. All right, let's draw a cast diagram. Like so. We start at 0, we go anti-clockwise in the positive direction. We're only interested in the first 2 quadrants. And because we're talking about sine, and this value is positive, okay, we put our angle in the first 2 quadrants. So it's going to be pi over 6 right there, pi over 6 in there, and we just read off our angles. So we're going to have big X is equal to pi over 6, and then pi subtract pi over 6, which is 5 pi over 6. This, of course, is equal to 2x. If you remember, we wrote x is equal to 2x right there. You can also see it here as well. So we just have to divide everything by 2, and we've got everything we need. So x is going to be pi over 12 or 5 pi over 12. Okay, so that's part one of this question.